Yo, so today let's talk about archival data. Um, Research can be hard, and sometimes getting data can be hard. So welcome. So today we're going to talk about, and I'll have to walk you through something that is arguably the most important methodological skill set. You need to have this skill set if you want to publish easy in top journals, and that is working with archival or secondary data. Now, when I say archival data, I'm talking about data that already exists out there in the real world and more like companies' financial record, SEC filing, patent database, platform transaction logs, government statistics, data that can be collected by someone else or for some other purpose, and that we researchers can repurpose to answer our very own research question. And I think that this is great. That you don't need to collect primary data, you don't need to collect data yourself, so you can go out there and get data that is already available and answer your question. So this is different from primary data collection, where you design survey, run experiments from scratch. So both approaches have their place. So I'm not saying that primary data is not good, but over the last decade, there's been a lot of dramatic shift towards archival data in top information systems journal, and there are very good reasons for this shift, which we will go into. So our goal today is to take you from understanding what data sources are available for you all the way through producing publication quality causal inference. So think of it as the complete pipeline from raw database to a paper that can survive review process. So why archival data? Why it actually matters? I want to break it down here. So the big picture here is capturing. The big picture here is captured in what I'm calling the core shift. For several decades, IS research relied heavily on survey. You send out a questionnaire asking managers about IT investment, their perception of IT value, and how they felt about technology adoption. Then you run a structural equation model or regression on those survey and responses. That approach worked and it produced some foundational research, but it has serious limitations. So what happened is that the field has moved from ask people what they think to observe what actually happened. So instead of asking a CIO how much they invest in IT, you can look at their actual financial filing. So instead of asking a user whether they trust an online platform, you can observe their actual purchasing behavior in transaction logs. So this shift has been enabled by an explosion of available data. Digital platforms generate massive behavioral datasets. Financial databases have become more accessible through services like WRDS, which is Compustat, and government data is increasingly open. So let me walk you through the four key advantages of using archival data. So with archival data, you're often working with thousands of firm or millions of transactions. So a typical survey study in IS might have 200 to 400 respondents. A typical archival data study might have 5,000 year firm observation or 500,000 users transaction. So that kind of sample size gives you statistical power that survey simply can match. So you can detect smaller effect. You can run subsample analysis, and your results are almost more robust. So a good thing again that I need to point out is longitudinal coverage. Archival data naturally lends itself to tracking the same entities over a multiple period of time. You can follow the same frame for you can follow the same 500 frames for 10 years. The the panel structure is actually this panel structure is what actually enables fixed effect, which lets you control for all stable characteristics of each firm that you can directly measure. Things like organizational culture, management management quality, industrial dynamics. And the thing is that you can do this with a one-time cross sectional data. So another thing I like about archival data is the fact that the the no common bias. So this is a big one. In survey research, the same person provides you both your independent and dependent variable. So if someone rates their IT investment as high and their firm performance as good, those responses are contaminated by the same cognitive bias. Optimism, social desirability, and consistent motive. So with archival data, your variables come from a different source. IT investment from maybe IT investment from SEC filing, firm performance from Compustat, and stock return from CRSP. So you see your data is coming from different source, not like a single source. So the bias that plagues the survey research is structurally eliminated. So again, a good thing again is the causal inference ready. And here is the repair of. So the panel structure of archival data enables all the quasi experiment techniques that top journals now expect. So because of the panel structure, you can actually do a quasi experiment. Again, is difference in difference, instrumental variable, regression discontinuity, and event studies. These are methods that require you to observe the same entity over time before and after some treatment or shock. So archival data gives you exactly that structure. So this makes archival data very, very robust. So let's talk about the major sources of archival data. So I have organized the major sources into 6 categories, and we will do a deep dive on several of these. But first, let me give you the high level map. So when it comes to firm financial data, this is the traditional backbone of archival data, and Compustat through WRDS, I think it's Wharton Business School, gives you standardized financial statements for thousands of publicly traded companies going back decades. Revenue, assets, RD spending, employee count, all this you can get from our WRDS. CRSP gives you stock market data, daily returns, trading volumes. These two databases often merge together are what most archival IS paper use to measure firm performance outcome. So if you're looking for performance outcome, you should look through Compustat, where you can get all these metrics like revenue, assets, spending, market data, daily return. So play around with this. We're gonna go through it, and so you understand. So IT specific data. This is where things get more interesting for IS researcher specifically. So the SEC EDGAR filing contains rich data about IT investments, cybersecurity risk, digital strategy. The now discontinued Hattie Hanks database was used to track IT budget directly. But increasingly, research are now miming 10K filings with NLP tools to construct IT related variables from unstructured data. So again, let's look up. There's also um, platforms and digital trace data. So this is a growing category. Think of App Store data, e-commerce transaction logs, social media posts, crowdfunding platform, sharing economy platform. Every digital platform generates behavioral data that can be used for your research. And we also see in the patent and innovation data. This is the USPTO patent view database. It lets you track patent filing, citations, and inventors. This is how you measure innovation output, technology trajectory, and knowledge spillover between firms. So if you want to measure innovation output, you should look at patents. So again, is the government and public data. We're looking at FCC, broadband data, consensus demography, Bureau of Labor Statistics employment data, Bureau of Economic Analysis GDP data. So these are essential. Both are primary source and both are essential. Both are essential. What am I saying? So these are essentially both as a primary data source and a control variable. So we also seeing specialized database. So Glassdoor for employee review, job rating, national. We also have the National Vulnerability Database for cybersecurity research, and just quite a lot of it. So let's look at Compustat. This is like the gold standard for financial database. And I think if you want to do econometrics or use secondary data, you should focus on this. So Compustat is accessed through WRDS. I think I have a video where I showed how to access Compustat. So WDRS is the Walton Research Data Service Platform. It's the single most important database for firm level archival research. So if you are going to work with archival data, WRDS access is the first thing you need to set up. So on the left side of the slide, you can see the key Compustat variable that IS researchers use regularly. So these are the various codes that you actually encounter in the data. You can see the art. The art is the total assets, the size of the firm balance sheet, the sales is the total revenue, the NI is the net income, the bottom line profit, the XRD is the R&D expenditure, often used as a proxy for innovation investment. The EMP is the number of employees. The MEGVOT is the market value of equity. So for these variables, you for these variables, you construct the derive measurement. Construct the derived me- you construct the derived measures that most papers use as a dependent variable. Also, return on assets is simply net income divided by the total assets. It tells you how efficiently the firm generates profit from each asset. So again, the Tobin skew is the market-based performance measure. So roughly, the market's value of the firm divided by the book value of its assets. So when the Tobin skew is greater than 1, the market believes that the firm is worth more than the sum of its tangible parts, which implies that intangible value creation, which implies intangible value creation. So in IS research, a high Tobin skew after IT investment is interpreted as evidence that IT creates tangible value. So on the right side is a step to get you started with 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 WRDS. First of all, verify that your university has subscription. Sometimes you can go through your university database. Most major research universities do. So to create an account with your university, you need the university email. Navigate to Compustat, specifically the North American database for US firm, and you just have to go through the process. So let's talk about the sec EDGAR filing and text mining. So the sec EDGAR is, I don't know if I pronounced that right, but that's the way I pronounce it. So this is a good mine for IS research. It is completely free. So the sec requires every publicly traded company in the US to file a regular report, and all those filings are publicly available on their website. So to walk you through the four filing types that matters most in IS research, the 10K the 10K report, which is important, which is the annual report. This is the most important one. It contains detailed discussion of the company's business operation, strategy, risk factor, competitive environment, and everything. So for IS researchers, the 10K report is available because companies discuss their IT investments, their digital their their digital transformation initiatives, cybersecurity risks, AI adoption plans. So this is discussed in unstructured text, which means you need NLP to extract structured variables from them. But the richness of this information is unmatched. So if you can get the 10K report and you can extract it, you can get a lot around IT investments and all those things. So the thank you is also a thing. So the thank you is a quarterly update. It's short and more frequent. So if you need within year variation, uh, an IT strategy disclosure, this is where you look. So the 8Q is the 8Q is filed whenever a material event happens, a data breach, a major IT contract, an acquisition. And these are particularly variables for event studies. I don't know if you know about event studies. Event studies is when you are me- you are measuring the stock market's reaction to specific IT related announcements. So if there's an announcement about a new AI tool, announcement about something, you measure the specific stock market reaction. So this is where the you the 8K reports are very useful. because, like I said, it's fired whenever a material event happens, a data breach, a major IT contract, an accusation. So these are particularly valuable for event studies. Then we have the Def 14A. A. This is the uh, this is the proxy statement which covers executive compensation and board governance. For also for IS research, for IS governance research, you can find information about the CIO compensation, whether the board has IT expertise, and how IT governance structures are organized. So now, if you look at the bottom of the bar, you can see the text mining pipeline. This is a practical workflow for extracting IT related variable from the EDGAR filing. You download filings pro- programmatically using EDGAR API. Then you parse the HTML or CGML formatting, extract specific section you care about, and these are just the steps. So the slide 6. Let's talk about digital trace data. So this is actually a very good one. So this is the category that is growing fast and is uniquely suited for IS research. So are because platform are our domain. So the table on the slide maps out the major five subcategories. App Store. The App Store gives you download count, ratings, review, pricing, updated history. So if you're studying app ecosystem dynamics, platform competition, or impact of app design decisions on user adoption, this is your data. So e-commerce platform like Amazon, eBay provides you listings, uh, prices, selling rates, and customer reviews. So research research on online reputation, fake reviews, price competitions, and platform regulations often draw from these sources. So again, we have the social media, Twitter, Reddit, Stack Overflow gives you post engagement metrics, network structures, rich text for sentiment analysis. However, I need to flag that API access has become increasingly restricted. Um, X or Twitter API in changed in 2023. This is a significant change which limited academic access. So you need to plan for this when designing your study. So if your study is based on X or Twitter data, I think you should reevaluate. Probably focus on Reddit, but Twitter would have given a rich data access, but because they changed everything their API, so it's almost impossible to get academic access. But trust me, boy, it would have been a rich source of data. So we are looking at crowdfunding platform like Kickstarter. Kickstarter provide project description, funding amount, backers count, and success or failure outcome. So this data is good for studying signaling, social influence, and information cascades. So we're also looking at the sharing economy, like Airbnb, Uber. Like Uber generates listing, pricing, reviews, and available data. The the Inside Airbnb project provide publicly available Airbnb data for many cities. So if you notice this that I put here, the warning box. This is really important. Always check terms of service and robot.txt before scraping. many platforms have become more sensitive about data access. Before building your own scraper, check whether pre-existing academic databases are available. Data sets on Kaggle, academic data repository, or through research partnership with platform. Some platforms have formal academic research programs that provide data access, so you want to check that too. So let's talk about the research pipeline. So this slide maps the 7 steps for archival research project, and I want to be honest about where the time actually goes in. So step one, research question. Everything starts with a theory-driven hypothesis, not let me download some data and see what is interesting. So that's data mining, not research. So you need a clear question rather than theory. What mechanism do you think? What mechanism do you think operates? What does prior literature predict? Why should we care? So step two, identify data. Once you have a question, you figure out what observable, measurable data could proxy for your theoretical construct. Let me say it again. Once you have a question, figure out what observable measurement data could proxy for your theoretical construct. This is the creative exercise. Your dependent variable might be firm performance from Compustat. Your IV might be IT investment measured from Thinkitex miming. And your control variable might include firm size, industry, age, and age from various sources. So what you do next is number three is acquire and clean. So here's the honest truth. These steps takes like 60 to 80% of your total project time. Raw archival data is messy. There are missing values, coding errors, merging problem, outliers. So most students underestimate this step massively. So you have to budget for it. Step four, build the panel. So your structure, your data in long formats, each row is one entity. Uh, each row is one entity in one time period from 001 in year 2019, from 001 in year 2020, and so on. This entity by entity time structure is what enables all the econometrics method. So now the next is to choose your method based on your identification strategy, your source of exogenous variation. Exogenous is like the independent variable. You select the appropriate econometric techniques. So we have a whole slide on this decision. Number six is the robustness check. A, you run and test a reviewer's you run every test a reviewer might ask for. So before they ask for, so the whole idea is you have to run and test everything that you think the reviewer will ask for before they ask you. So alternative specifications can be one, placebo text, falsification test, subsampling analysis. Step 7 is publish. You present your results with your publication quality tables, report size, not just p-values, and tell a clear causal story. So the important note at the bottom, you see, you often discover data issues at step 3. That's before that forces you back to step 2. So your identification strategy at step 5 might not work, sending you back to step 1 to reformulate. So this is normal, and research is iterative, so don't be discouraged. So data cleaning. So on the left side, I have listed 8 essential cleaning tasks you face with virtually all archival datasets. Handling missing values is your first challenge. Do you delete observation with missing data? You know, that's like listwise deletion, which reduces your sample size but keeps the analysis simple. Or do you impute missing variables using statistical techniques? There's no universal answer. It depends on why the data is missing and how much you lose by deleting. So I have a lot of things here. You can see the when Sorais extreme values at first and ninth percentiles. Let me explain. Uh, Let me explain this with the the box on the right. So imagine you have a profit data from 1,000 firms, and 900 of them have profit between negative 500 million and positive 500 million. But one firm, let's say Apple, has profit of 100 billion. That single observation will heavily influence your regression coefficient, potentially distorting your results. So when summarizing at the first and the 99th percentile means you replace any values below the first percentile with first percentile value, and any values above the 99 percentile with the 99 percentile value. This observation stays in your data. You're not deleting Apple, but you're capping its extreme influence. So this is a standard practice in archival research, and reviewers expect to see that. So another thing is constructing derived variables. You often need to calculate ratios, rate, and indices from raw data, and ROA from net income asset, Tobin-Q from market value and book value, IT intensity ratio from IT spend and revenue. So verifying merges is critical. When you link Compustat to maybe CRSP or to EDGAR, check your match rate. If you started with 10,000 firm year observation and only 4,000 survived the merge, you need to understand why, whether the unmatched observation introduces bias. You also need to address survivorship bias, and firms that exist the data sets through bankruptcy, acquisition, or going private aren't random. They are systematically different from firms in that stay. So if you don't account for this, your result may not only apply to survival firms. So I think I'm talking too much. So choosing your econometrics method. So here is a very important. So the table is decision guide, and the decision rule at the bottom captures the fundamental principles. So let me walk you through this very fast. So panel fixed effect. So this is the baseline. So if you have the same entity observed over time, you want to control for all stable differences between them. Firm culture, industry position, management quality. You use fixed effects. The equation on the right shows. I think I need to plug my battery. So the equation on the right shows the key alpha of the equation is on the right is actually the equation for fixed effect. I'm not going to go through that. So the next is difference in indifference. Difference in difference is the workhorse of causal inference in archival IS research. You need an event or a policy that affects some entity but not others. So the critical element is the parallel trend assumption. So before the event, the treatment and the control groups must have been trending in the same direction. So if they if they were already diverging, your estimate is biased. So reviewers will ask to see the pre-treatment trend. So basically, you need an event or policy that affects some entity but not others. So the critical element is the parallel trend assumption. So again, is the instrumental variable. The instrumental variable what what you reach for when your key variable is endogenous, when there is reverse causality, or when there is omitted variable bias that fixed effect cannot solve. You need an instrument that is correlated with your problematic variable but uncorrelated with your outcome except through that variable. The two conditions are relevant, which you must test statistically. So the first stage F statistics should be above 10, and the exclusion restriction, which can be only be argued theoretically, not through tests. So finding a convincing instrument is the hardest part of archival data research. So again is the regression discontinuity. This actually works when treatment is assigned based on a score cutoff. For example, firm above certain revenue threshold must comply with a regulation, while firms below will not. So right around that threshold, firms are essentially randomly assigned to treatment and control, giving you a local causal estimate. Again, is a propensity score combined with DID. This is useful when firms select firms self-select into treatment. You first match treatment with you first match treatment firm with similar untreated firms based on observable characteristics, creating a more comparable sample, and then apply DID to that match sample. So event study design, event study is another one. So this is also a very good one, which traces the treatment effect dynamically over time. You estimate separate effect for each period before and after. So this serves as double duty. The pretreatment coefficient should near zero, more like confirming parallel trends, and the post-treatment coefficient should show how the effect views over time. So merging multiple data sources. I'm not really obviously. I'm just trying to give you the whole idea. So here the opening captures it. Most archival paper combine 2 to 4 data sources. The challenge is linking them together, and that comes to having common identifier. So the table below shows 5 key identifiers you will encounter in firm level research. So the GV key is Compustat primary firm identifier. It is stable, unique, and reliable. So The next one, PERMNO, is the CRSP stock identifier. It is also reliable, unique within the CRSP. And these are just the identifier which I will not have to go through because of time. And robustness check, I cannot overestimate the importance of those. MISQ reviewers who challenge your causal claims aggressively, and you need to be prepared. The rule of thumb at the bottom says it all. If a reviewer can think of a robustness check, you should have already run it. So let me walk you through the 6 essential categories. The alternate DV, alternate dependent variable definition. Suppose your main result uses ROA as the performance measure. A reviewer will ask, does this hold if you use WSQ instead? What about the stock return? Uh, what about the sales growth? If your results only appear with one particular measure, that is red flag. You want consistency across many operationalization. Again, alternate specification. Does your result survive if you add more control, drop some, use a different functional form, log versus levels, switch to OLS, to, to fixed effect, to random effect? You know, Stability across specification signals a robust finding. Again, is subsample analysis. Does does the effect hold for large firm and small firm, for tech firm and non-tech firm? You know, in a pre 2008 and post 2008 period, across different geographies. You know, Subsample analysis reveals whether your finding is generalizable or driven by a particular subset. Again, placebo effect and falsification. These are particularly important for difference in difference design. If your if your treatment happens in 2015, you know, we run the analysis pretending it happened in 2012. If you still find an effect with the fake treatment date, something is wrong. You know, so your result is driven by treatment, is driven by some other trends. Similarly, test whether your treatment affects outcome. Test whether your treatment affect outcome it shouldn't affect. So generally, just if your IT governance policy supposedly improves cybersecurity but also appears to improve the firm weather forecast accurately, you have a problem. So again, is the Hackman selection correction. So you have to make sure that you put this robustness check in mind. Again, is for the Hackman selection correction. If your sample size suffers from selection bias, for example, for example, you're only studying firms from voluntarily adopted IT governance policy. The firms that adopted aren't random. So you need to check all these things. I'm not really going into details or explaining everything because I just wanted to have a general idea before you choose to use archival data. You need to know what to expect. So again, the instrument diagnostic, if you're using an independent variable, you need to show that your instrument is strong. you know the first stage F statistics well above 10. You need to also check all those things. So common pitfall I see, um, if you have structured each pitfall, I have structured each of these pitfall with examples. Number one is pitfall one, measurement validity. Just because a variable exists in your database doesn't mean it measures what you think it measures. The bad example is Leslie saying that we measure IT capacity using total IT spending. The good example cites a theoretical foundation. Let's say we follow a framework by, how do I pronounce his name? Bajawaj 2000 and 2000 framework, and uses a ratio IT spending as a percentage of revenue, supplemented by text analysis from 10K filing. Reviewers want to see that you have thought carefully about whether your proxy actually captures the theoretical construct. So you have to make sure that your proxy captures the theoretical construct you need to use. So the number two is the problem of endogeneity. This is the simple biggest threat to archival data. A bad example is naively regressing firm performance on IT spending without knowing that the relationship might run reverse. You know, profitable firm might invest more in IT rather than IT causing profitability. It might be a issue of reverse causality, or there might be an omitted variable bias like management quality that drives both IT investment and performance, which is an omitted variable bias. So the good example is using an identification strategy like instrument, difference in difference design, or at minimum a lagged variable with a clear theoretical justification. So number three is more like a temporal mismatch. If you measure IT investment and firm performance in the same year, you can't distinguish cause and effect. That's fact. IT investment takes time to produce result. So the standard practice is to lag your independent variable. Measure x at minus measure x at time t minus 1 and at y at time t. This ensures your temporary ordering, which is necessary though not sufficient condition for causality. So it's a lot of work. Statistical and economic significance. The bad example, the bad example is you report that the coefficient is significant at p less than 0.01 and stop there. But the statistical significance just means that the effect is unlikely to be zero. It doesn't tell you whether the effect is big enough to matter in the real world. The good example translates the coefficient into the economic term. A one standard deviation increase in IT investment is associated to like 3.2 increase in ROA. So representing like a 4.7 million in additional profit from medium firm. So like give and take. So yeah, you can see the technical skills. So here you don't need to master all three languages. You can use Stata, you can use R, you can use Python. So depending on what you want to use is okay. You can stick with Stata, which I think is good. So you need to find one and just focus on it. So I give an example paper here, and I have selected five papers that each exemplify a different approach to archival data in IS research. And when you read this, you don't just read it for finding. You study the data source, the identification strategy, and everything. So these are the data. Like the Matthias et al. Is a masterclass in construct operationalization. They use the Hattie Hanks IT data merged with Compustat, financial, and panel fixed effect. Pay attention on how carefully they define and justify their measure. Also, these are like some of the papers you need. The second one on TAMBI and HATE tackles the IT productivity paradox using an instrumental variable approach. They study how they select and justify their instrument for IT spending. This is where most IV papers struggle, and they do it well. So the next one is a natural experiment on dating platform. They exploited a natural experiment on online dating. This is a great example and how platform design change creates opportunity for causal identification. So the next one, Joshi and Kuhn demonstrate variable construction through NLP on 10K filing. So if you're interested in extracting IT related signal from text file, this paper shows you how. So the other one combines consensus and BLS government data to study internet adoption and wage inequality. Is an excellent model on how to work on public data. So below, I also added some for textbook Woodridge Introduction to Econometrics. These are like some of the books you can also look to get examples. So the 8 months learning roadmap. I'm still in my learning foundation, month one. So it takes time. You shouldn't rush yourself when it comes to econometric. You shouldn't really rush yourself to learn. It takes time to learn, and take your time to learn, which I strongly recommend. So first, the first priority is getting WRDS assessed through your university, and once you have a seat, once you have that, download Compustat database, pull like 10 years of data from SP500, and just explore it. Get comfortable with the variables, the structures, the quirk, practice basic panel operation in Stata and R, and read Woodridge chapter 13 and 14, which covers panel method, and also study 2 or 3 of the exemplar papers I discussed. In 3 to 4 months, just start practicing the causal inference method. Find a policy change that affected some firm or region but not others, and practice difference in difference analysis with real data. Learn to query the sec EDGAR programmatically using Python. You know, merging multiple data sources, Compustat with CRSSP with panel data. Run your first instrumental variable regression, and read the and how do I even pronounce this? Angries and Pisky, chapter 4 and 5 on instrumental variable and DND. Months 5 to 6 is advanced. This is where you put it all together, extract variables from unstructured text using NLP, implement a complete identification strategy from start to finish, and to produce publication ready regression table. Practice all robustness check we discussed, and draft a method section following the MISQ convention. Even if it's for hypothetical paper, writing it forces you to articulate your approach. Month 7 to 8, apply to your research. Now take everything you've learned and apply it to your actual dissertation topic. Identify which archival data sources are relevant to your research question. Build your data sets, design your identification strategy, run your preliminary analysis, present at your department seminar and get feedback. And apply this to your research. So yeah, apply this to your research. This approach. Let me make this concrete. So here, approach one, difference and difference. Approach two, instrumental variable. Approach three, natural experiment. Let's say for difference in difference, suppose firms implement AI governance policy at different time. Let's say some in 2023, others in 2024, some haven't. You pull their financial data from Compustat and mime their 10K filing from SEC EDGAR for IT governance disclosure. Your treatment is the adoption of IT government policy. You compare productivity metrics or security incident rates before and after adoption for treated firms against the contemporaneous change in firms that haven't adopted yet. If the parallel trend assumption holds, meaning treated and untreated firms were trending similarly before adoption, the DID estimates give you the causal effect. So um, these are like something things you can do. So the key takeaway from here is first, archival data combined with quasi-experiment method is dominant paradigm in top ICE journal right now. Your identification strategy, the source of exogenous variation is everything. The most sophisticated econometric techniques in the world can't rescue a paper without credible source of identification. Before you write a single line of code, figure out where your exogenous variation comes from. Third, data cleaning will consume 60 to 80% of your time. This is not a failure of efficiency, it is the reality of working with messy reward data. So budget for it in your project timeline. You don't get discouraged when you're spending weeks of data preparation. Fourth, always merge multiple data sources. Source a single source studies are more vulnerable to measurement validity concerns. So when your independent and dependent variables come from different sources, you strengthen both your measurement and credibility with reviewers. Fifth is robustness check. Robustness check are not optional; they're expected. Prepare them proactively. Don't wait for reviewers to ask. The more robust you can show upfront, the smoother your reviewer's process will be. Six, learn by doing. Download real data. Try to reproduce their results. You break things, you make mistakes. That's how this method becomes second nature. Not from reading them, but from wrestling with actual data. Master this method, and you can publish the best venues in your field. So this is typically everything you need to know. I don't expect you to know everything through this research or through this presentation. I mean, I don't know everything. I just want you to understand that secondary and archival data can be actually be something that is very important and very valuable.